Blocking assignment behavior in simulation. As explained previously, in case of blocking assignment, first right-hand side of the first expression is evaluated first, it is assigned to the LHS variable, and goes to next statement and repeat the same. In this example, in an always block with sensitivity list as a clock, C is assigned with B first, and B with a next. Assume that, at a given point in time, the values of variable at the end of previous clock was, A is 2 and bis 8. Now let's check what will be the values of the variables at the end of this clock period. The RHS of all statements are just values and there is no need to evaluate them. Thus first, C will be immediately assigned with value of B which is 8, and B will be assigned with that of A, which is 2. Thus the results are, C equals 8 and B equals 2. Now in the same example, let's reorder these statements as shown here. Now, B will be immediately assigned with value of A, which is 2. Next, C will be assigned with value of B. With the previous expression, value of B got changed and get assigned immediately, and it will result in B when the next statement is executed. Thus C will be equal to 2. In short, in case of blocking assignment, the order of statements within an always block matters. This behavior is same as a programming language like C or C++. The name blocking is derived from the fact that evaluation of any statement is blocked by its previous statement, if there is any. Non-blocking assignment behavior in simulation. In case of non-blocking assignment, all first right-hand side expression of statements is evaluated first using the values from the previous time slot. They are not assigned immediately, but the assignment happens simultaneously when that time slot is getting finished. Here are the same examples from the previous blocking slide, but instead of blocking assignment, non-blocking assignments are used. In the first case, at the end of time slot, C will be assigned with value of B from the previous time slot, which is 8. B will be assigned with the value of A from the previous time slot, which is 2. Thus the results are, C equals 8 and B equals 2, which looks obvious from the expressions. The actual effect of non-blocking assignment will be seen, if the statements are reordered. Here, at the beginning of the time slot, all RHS expression are evaluated with values from previous time slot. Here, all RHS are straight values, and there is nothing to evaluate. But, after evaluation of RHS, the actual assignment of the values to LHS will not take place immediately, but will be done only at the end of the time slot. Thus, B will be assigned with the value of A from the previous time slot, which is 2. And C will be assigned with not the value of B from this time slot which is 2, but from that of previous slot, which is 8. That is, B will be equal to 2 and C will be equal to 8. This result is exactly same from the above example. In short, in case of non-blocking assignments, the order of statements within an always block don't matters. This behavior is different from a software programming language like C or C++. The name non-blocking is derived from the fact that evaluation of any statement is non-blocked any previous statements.